Welcome to Getting Started with Server-Side Swift. I'm your presenter, Dion. A little bit about myself before I get started. I've been a software developer for almost 20 years now, and I've been specializing in development in the iOS space since 2010. I've been doing Swift development since day one back in 2014. I run my own company known as BrightDigit, which you can find at brightdigit.com, and I've been also running my own podcast, Empower Apps, which has been up and running for 3 years, specializing in the areas of development in the Apple space and Swift. Today we'll be talking about why bother learning about server-side Swift, differences from iOS development, the Swift server workgroup, and the varieties of technologies and frameworks that they've made available. Then we'll be talking about Vapor specifically and deep diving into building first a Hello World app, secondly a CRUD application. And we'll talk about the different tools that can help you in building that application. Then we'll get into FluentKit and how to hook up that application to your database. Lastly, with our built application, we'll talk about the process of deploying to the server on the cloud. So let's begin by talking about why. Why should you be interested in learning about server-side Swift? One thing that server-side Swift gives you is the ability to build a full-stack Swift application. That means everything from the server to the watch to the phone to the TV to your console application can all be built in Swift and deployed easily to a Linux cloud server. If you're interested in learning more about full-stack Swift application development, you'll want to check out my video from last year on full-stack Swift from the server to the watch, which I did for iOS DC Dev Camp, if you want more details. The other use case I've seen for building a server-side Swift application is testing. In some instances, you might want to throw up a quick server that mocks or replicates the behavior of a real server in the cloud. If you can do this all in Swift, that helps you in a lot of ways with performance and reliability and testing. The other point that's been made about server-side Swift is the performance benefits. And there are a few listed out on the server-side workgroup page. One of these is its small footprint, deterministic performance, and its quick startup time. If you're interested in learning more about these, I would highly recommend checking out the server-side Swift workgroup page at the URL below. Now that we've gone over some of the benefits of server-side Swift, let's talk about what differences folks like us who are iOS developers, what we'll run into. For one thing, we have the difference between a server application and on-device application. Things like dealing with multiple users or dealing with a central database with multiple users is going to make a big difference in your application. Just the fact that you have to handle multiple requests from a variety of locations is going to make a difference as opposed to your iOS application. The other thing is the difference between simulator and on-device development. If you've ever developed a Mac app, you know you don't have the convenience of resetting your simulator. However, there are some benefits with server-side applications and the ability to use something like Docker to quickly throw up a server and reset it at any time. We'll talk about Docker more later in our presentation. The next thing is the difference between developing for Linux and the Mac. Swift is available on Linux and is easily usable, and is usually going to be your target when you build a server-side application. However, one thing to think about is that there's several libraries that just simply aren't available on Linux, or you might need to import some libraries in order to patch over any differences between the operating systems. One example I've run into is if I'm going to do any networking stuff, I need to make sure I import the framework Foundation Networking. If I don't import Foundation Networking, I can't do things like deal with URL sessions and URL requests. If you're dealing anything that is old enough that it requires Objective-C, for instance, those libraries won't be available on Linux as well. Other things to think about are the differences between the front end and the back end. So UIKit won't be available, or SwiftUI won't be available on the server. And obviously with back-end versus front-end technologies, there are differences between having to design and implement things in different ways. Now that we've gone over some of the major differences, let's talk about the Swift server workgroup. This workgroup is the base for all other frameworks in its development of different libraries that will be available to you both on Linux and the Mac. One of the basic libraries that's used throughout server-side Swift is SwiftNeo. SwiftNeo provides all the networking technologies as well as the promises and various logic statements that are required in order to build your server-side Swift application. Another library you probably are going to end up using is Async HTTP Client. Async HTTP Client is an evolution from the basic URL session requests that we've been using, and I highly recommend using this with any server application. And I also recommend taking a look if you're interested for using this library for your iOS application. This is a lot more and is a lot more involved and is going to be the basis if you're going to make any outside REST API calls with your application. So now that we've talked about the basic libraries, let's get into what the frameworks. Async HTTP Client is a more evolved library from Foundation Networking and URL Session. If you're going to be doing anything on the server, I highly recommend checking this library out as a way to call REST API calls and making networking calls outside of your server. So with SwiftNeo and Async HTTP Client out of the way, let's talk about some of the frameworks that are built on top of those technologies. The first of those frameworks I want to talk about is a new one, Hummingbird. Built by Adam Fowler, this is a very basic HTTP client server application for doing very simple REST APIs without any of the cruft that might come from other libraries. It's definitely worth looking at just to try out and see what's out there for alternatives. If you're in the Amazon space, you're going to want to look at Smoke. Smoke is Amazon's Swift backend framework for building server applications. And if you're doing anything with EC2 or anything like that, this is definitely worth taking a look at. The alternative, of course, on Amazon is building an application using AWS Lambda, which is a capability that we have with Swift. As a matter of fact, there was a talk a few years ago at WWDC about building your own AWS Lambda application in Swift. I've done this before, and it's a really easy and fun process to go through, so I definitely recommend checking this out as well. Today, we're going to look at Vapor. Vapor is by far the leading technology and framework for building server-side Swift applications. And we're going to start by building our own Hello World application. If you want to follow along, you want to take a look at my Git repo at this URL here, lists.1. This will forward you to my GitHub repo where all our code we'll be using today is located. Unlike building an iOS application, we'll be using Swift packages to build our server-side application. In order to do this, you can do this through Xcode by going to File, and then New, and then Package. We're going to create an Xcode project and then put our Swift package as a subdirectory in there. When you go ahead and tap New, you can just go ahead and add this to an Xcode project for our iOS application. The other way to start a Vapor application is by using the Vapor toolbox. If you have Homebrew installed, you can use Brew and install Vapor, and then go ahead and say New, and then type in the name of your application. And there are a variety of templates that come with Vapor as well. If you're a command line person like me, you can also use Swift package in it to go ahead and create your application or your Swift package from scratch. Here's how the structure of our Xcode project will look. We have an Xcode project containing an iOS app target. That iOS app target will reference two of the libraries located in our Swift package, one containing our UI code and one containing shared code between the server and the UI. We also have a Swift package, which is also contained within our Xcode project. The Swift package will contain 4 products: a UI library and a shared library between the application and our server application. Also, we'll have a server application and a server library as well. In the end, we'll have listsd, which is our server command for running our server, and listapp, which is our iOS app. So here's what the code will look like for our package.swift file. You'll notice we have our 4 products, our 3 libraries are in our executable for the server, and then that most of our code for the server will be contained in the list server kit. This list server kit references Vapor, which is one of our dependencies in our Swift package. So as you can see, we have our main.swift file, which just contains the code that runs server app.run, and then our server app class contained in our server library. And this contains most of the code we'll be using to start our server and get it going. So let's create our first route. Inside configure, we're going to register what's called a route collection. And the way a route collection works is it needs to implement a method called boot. If we didn't go with this methodology, we could just go into the app itself and just say .get and start specifying our call, but we want to keep this app a little bit more organized. So instead, we're going to be using the route collection. In this case, we have a hello world controller, which implements this, and then it sets up a get call for our path, in this case, hello name. From hello name, it will have a parameter known as name. We can specify this with the colon prefix on our route. Next, we just go ahead and we say require name from the parameters property on the request, and that will get the name for us. Therefore, when we call curl, for instance, and we type in world as the name, it will give us hello world, like so. So we've created our first route. Let's talk about how to parse content, for instance, in a post type request. So we're going to set up a struct called person, and this person has to be codable in order to be used within Vapor. Next, we're going to go ahead and we're going to change our hello world controller by adding a new route, in this case post, which contains the content of a person object. For it to work with Vapor, we just need to extend person to implement content. And there really is no methods or any sort of properties that you need to implement. You just need to make sure to mark that as a content type struct. Once you've done that, you can then just use the default decoder in Vapor to go ahead and decode that JSON that's thrown into the post. And we already have our property for name. And then from there, we can go ahead and call hello with the person's name. So when we call this through curl, for instance, we get, if we type in, pass in a JSON object with the name Leo, we get hello Leo. If we're doing this, for instance, in Swift on our iOS application, we could just create a URL request, attach the body, which is the JSON encoded body of a person object, and then we go ahead and make sure we add the HTTP header field for the content type being JSON. We say post, and then we can make our URL request from there. So we've created a server-side hello world application. Let's look at building an actual CRUD application. And by that, I mean an application that taps into a database, creates, reads, updates, and deletes information from that database. And there are a few tools that can help us out. One of these is ngrok, or local tunnel. If, for instance, you're doing any sort of application where you can't just use localhost to make calls, for instance, if you're doing Apple Watch development, you might want to look into these applications. They have free versions which allow you to have a quick subdomain that you have access to, and it will go ahead and you can use that in your iOS or Watch application in order to call your local server. Another one to look at is Postman and HTTP-GET if you want to test different HTTP calls. That's a great way to do that. And then if you want to listen into what your Watch or iOS application is doing, take a look at Proxyman or Charles, which have been pretty popular with the community. But there's one other tool that I want to talk about today that's going to be super helpful if you're doing any server-side development, and that's Docker. Docker has grown in popularity quite a bit in the last 10 years, and it's a great way to try out your server-side application outside of the Mac OS space to see if it works. So for instance, if you're worried about something like Linux compatibility, you can do that using Docker just by running a quick command and building your application within the Linux OS. If you're doing this on ARM, you'll have to use the ARM Docker image, which is located at the URL below. But there's also an official Swift Docker image available to you as well. That's also located at the other URL in this slide. The other thing that Docker gives you is the ability to set up like a totally custom environment. Let's say you want to set up a custom environment with Redis or with Postgres or any other sort of server application that you need in order to get your server-side application working. You can set up a Docker file, which is a whole other talk, to set up that custom environment and get it going. So the last but not least is it's a really easy way to install server applications on your own Mac dev environment. I've gone away from installing Postgres, for instance, on my machine, but instead installing it via Docker and then setting up a port so that I can talk to my Postgres database. Here's an example of a code or a command line for setting up a Docker server for Postgres. And what this does is it allows me to connect to this database as if it was my local host, and then I could just simply trash it or trash the container, and then start from scratch to see what starting from scratch would actually be like. So I'm ready for deployment when that comes. So we talked about Postgres. Let's talk about how we're going to talk to Postgres with our Vapor application, and that is going to be through Fluent. Fluent is a series of libraries for calling into the database via Swift. And they're specially set up for Vapor. So this is the way we have our Swift package. What we're going to do is add another dependency to Fluent, which will be used by the list server kit product. And then via a special driver for Postgres, we can go ahead and access Postgres through Fluent. Fluent supports a variety of other databases, such as Maria or MySQL or Mongo. You'll definitely want to check out the documentation at vapor.codes for more details on what other libraries and servers are available. There are 4 components to getting your database set up in Vapor. The first one is going to be the connection. So here we have our package.swift file with Fluent added. And then here's our code within our server.app struct, where we've added a few things to get the database up and running. Let's go to the bottom here, and we see the bottom part where we have all our changes with things like the Postgres connection, as well as telling it what database to use. So under our configure, we get the database configuration from the environment object, and then we go ahead and say self.app.databaseuse, and then that has the information in the database configuration tuple to set up our database. We see here at the very top what's called the default Postgres SQL config, where we assume if we're doing development, we just want to connect to localhost with the username lists. And then underneath there, we have what's called Postgres SQL config, which pulls from the environment the database URL. So we can set that up in the Xcode arguments section under the schema. And that will set up the Postgres configuration based on the URL we pull from the database URL. And then database configuration, which then sets it up as the default Postgres database for our application. Most cases, you're only going to use one database, so that should be sufficient for setting this database configuration up. Now that we've talked about setting up the database connection, let's talk about this little part here at the bottom, adding migration. What's a migration? So in many cases, you're going to want to use Vapor for actually creating your database tables and various information that you want to import. And so you can do this all within Swift, which is fantastic. So here we have an example of our list item migration, where we've set up a table, which we already have a name for, called list item. We set up an ID, which by default is just simply a UUID. That's our primary key for our table. We have a required title to our object, and then like a completed at date, which is optional in this case. And then at the very end, we have create, which go ahead and creates our table. We can revert if we want to undo what we just did and just simply delete the table within this migration structure. Let's look at our database model. And there's two models really you're going to be working with. One is the database model, for which basically hooks up the table row to an actual Swift object. In this case, this is our database model with a scheme. Like I said, we have a table name called items. It has a ID, which has to always be optional, because if you're creating a new object, it doesn't have an ID until it's been saved to the table. We have a non-optional title string and a completed at date, as well as 2 initializers for creating a list item model. Lastly, we're going to need a model for our HTTP requests. One for creating a list item, and then another one for returning a list item from the database. In this case, our list item contains an ID. So this is the one for pulling a list item from the database. And then we have list item request, which doesn't contain an ID. And this is the one that we're going to use when we want to pass a list item from our iOS application to the server for it to create a row in the database. There's a couple of things we're going to need to do so that it's usable within HTTP, similar to how we had to do that with person. We also have to extend it to use content. And then we also have a helper method here, which takes a list item model, basically a row from the database, and turns that into a list item so that it can be used in an HTTP response. So now that we went over the four main components of Fluent, let's now get into how to do CRUD operations. And the first one we're going to look at is a basic read or get, where we pass in an ID and we get back a list item. Here's how that's going to look. So we have get, which we've passed in as part of our boot for our root collection, and that's going to get it a request. We then go ahead and we get the ID from the path that's passed in to the request. If we don't get an ID, we just return back an error, in this case a bad request error, which I believe is 400. And then from there, we query from our default database, and then we filter based on the ID. We return the first object that we get back. If there is no object, in other words, if it's an optional nil, because first can be nil, we then just basically return 404. Otherwise, we go ahead and try to convert that to a list item. So we can return that in our HTTP response. We can shrink that down quite a bit by using find. Find is kind of a shortcut, which does the query in the first for us, and it just simply finds it based on the primary key, in this case ID. So we don't need to do query and then first. Query is quite powerful, so if you want to do filters on any other fields, or you want to do group bys or sorting or anything like that, query is the main way of doing any sort of building of SQL queries within Vapor. So you'll definitely want to check query out. But in this case, we just need to simply find it based on the primary key, and that's what we end up doing here. So you notice a couple of things that we've been using, this request event loop .future, as well as this unwrap and flat map throwing. What do these do? Well, this is one of the basic structures of SwiftNeo, and it's called an event loop future. Basically, if you've ever used a promise before, it's very similar to that, and there are a few methods you're going to want to know. Map, for instance, is pretty easy to understand. That just basically converts one type to another. Flat map throwing is for dealing with cases where you want to convert an object to another, but it could possibly throw an error, and that's what flat map throwing deals with. Now, flat map is if, for instance, you get something from a database and then you have to make another asynchronous call to another REST API or make another database query. You'll want to use flat map so that you don't end up with an event loop future inside an event loop future. Flat map flattens that for you. Unwrap is when you're dealing with an optional where you want to replace the optional with something else, such as an error or another object. Or even you could pass in a closure of some sort. Unwrapped will deal with that. And then lastly, there's transform, which is simply map, but it only is for using it for returning a static value that you already know it's going to be. So oftentimes I'll use this, for instance, if I've done some sort of write operation and I want to transfer it to a HTTP status of 200. That's where transform is super helpful. So we talked about read with get. Let's talk about read with a list. So instead of returning one item based on an ID, let's return more than one item, like a whole entire table of information. So here's an example where we're using query to go ahead and call all, which basically is basically a select all from that table. And then we use flat map each throwing, in this case, like it's map each object and convert it to a list item and then return it as an array of list items, which is what we see here. Again, query is super powerful. All is just one of the methods for getting all the results back from any sort of filtering that goes on. So again, query is definitely a great place to look if you want to know different ways of filtering and manipulating your data from your database. Here's an example of create. In this case, we're doing the decode that we did previously with person. And then we also are turning that request item into a model. Now, like I said, the model constructor doesn't need an ID if it's not already saved, but when we call create, it'll go ahead and make that async call, which will then save that row to the database and then update list item with its ID. So we want to go ahead and transform that back to a list item. And then we're going to call flat map throwing, so that way when you save an item to the database using an HTTP request, we get back a list item with its new ID for the user. Then of course there's delete. In this case, we need the ID. If we don't have the ID, we return a bad request. We go ahead and call find to find that object based on the ID. We unwrap and return a not found error if there is no object with that ID in the database. Then we call flat map to go ahead and delete that object. And in this case, I want to return a custom HTTP response, no content, because there's no content attached to that delete operation. Lastly, we're going to put all this together with update. Update will not only decode the list item request, but also pull a parameter with the ID. So we go ahead and find that object based on the ID, and then we go ahead and return not found if no object with that ID exists. And then it goes ahead and it takes that model and it updates it based on the data in the item request. And then we go ahead and call model.update and transform that into the updated model. And then again, list item to convert that model into a HTTP response of a list item. Now that we've gone over setting up our application, let's talk about how we're going to go ahead and deploy it. Now, one way to deploy something like this is by just deploying it on a server in the cloud. This might be the easiest, not necessarily easiest way, but probably the most widely available if you're using something like DigitalOcean or EC2 or Linode. The easiest way, the most popular way to go ahead and serve HTTP is by setting up an Nginx server. Here's an example of my configuration for Orchard Nest, which is a server-side application I run for Swift blogs. As you can see here, the important part is the proxy pass, because what you're going to be doing is you're going to have it passing the proxy over to our Swift application, which will be running in the background. And then if you want to make sure the Swift application is consistently running, you're going to want to look at something like Supervisor, which is basically a way to run our Swift app from the command line and make sure it's consistently running in case a crash ever happens or something, some issue happens with the server. Here's an example of the database setup and the setup of my application in Supervisor. As you can see, you can pass in different parameters to the command. We have our environment variable here for our connection to the database, as well as what user we want this application running on and what logs we want set up. If you want to go even easier and maybe even cheaper, I would highly also recommend looking at Heroku to get started. Because with Heroku, all you really need is the build pack that is set up by the community. Once you have that build pack attached to your instance on Heroku, all you have to do is set up your proc file to run your server application. So in this case, here's the example of the command I run to set up a Heartwitch server, for instance, for my app Heartwitch. I simply pass in the name of the command and then whatever subcommand I need, in this case serve, in order to run this command after it's compiled, and then what the host name and what port and things like that, which Heroku can commonly give you. Thank you so much for listening to this presentation. Let's go over what we talked about today. Why we want to use server-side Swift, or why we should at least dabble into it and learn it. What frameworks are available, how to set up a server-side app, how to build a whole CRUD application, and lastly, how to deploy that application to the cloud. If you're interested in learning more, I highly recommend checking out things like how to set up your application using AWS or Lambdas, managing an event loop future and the variety of methods that are out there, how to use new features like async and await as soon as they're released and ready for the server, how to deal with things like job queues, authentication and security, and lastly, how to tap into technologies like CloudKit sign-in with Apple or push notifications on your server-side application. If you want to learn more about some of the topics we talked about today, you can check out my talk on full stack Swift at the YouTube URL here. Or if you want to know more about Swift packages, you can check out my talk from this year at Swift Heroes on Swift packages, dependency management of the future. Thank you so much for attending this talk, and I will take questions.